this was done. Only the 4 metros had the privilege of looking at the television sets. And at that time, what was realized is like today's direct-to-home television, and it was a direct-to-community set. The front-end hardware was all built within the country, and black and white television sets of the ECIL was used. And for 1 year, it demonstrated that we could reach out to the villages and communicate with the farmers and the villagers, giving them information about farming practices or the health and welfare activities and the like. So this was an experiment which was conducted, a unique experiment, and reaching out to 2,400 villages, and the government quickly got convinced that space technology can help us reach the entire country. And if you were to make use of the existing technology at that point of time, you can imagine a tower had to be microwave towers at 1 kilometer interval you had to put over the entire 3.5 million square kilometers of India. Would have been a huge task, and also it would have been time consuming. Next slide, can you move? See here, this church actually was the place where the first sounding rocket was assembled and launched. And in fact, it was the Vikram Sarabhai had to convince the fishermen that through the priest of this church, that today if you vacate this place for conducting experiments, space science experiments, one day the country will benefit. I will just show you how this particular statement has got vindicated. See, this shows that entire process. Now the first sounding rocket was launched using the assembly activities done in this church, and the fishermen were convinced that you need to vacate this space for this experiment. This was in the 60s. By 1999, using the satellite images, looking at the color of the ocean, and through the color of the ocean identifying chlorophyll, and through chlorophyll identifying the fish's food chain and the thermal front together, we were able to provide to the entire coastal fishermen community through an entity in Hyderabad called Indian National Center for Ocean Information System, a specific information about where to go for fishing. Now this process alone saves to the country between 15 to 20,000 crores a year, because the fishermen do not have to spend extra fuel, petrol and diesel. And that started in the year 1999. Now last year, when we completed our navigation satellite, that is a constellation of only 7 satellites providing us equivalent of geographic positioning system. What we have demonstrated just a month back in the Kerala coast is that a fisherman carries his handheld mobile, and a small gadget is fitted into the boat, and this gadget receives the signal from the Navik constellation and determines the position of the boat, and also through the messaging system identifies where the fisherman has to go for the fishing. And by communicating between the mobile and the unit which is fitted into the boat through Wi-Fi, the fisherman with an app on his mobile gets to know where to go in the form of a compass needle. So he is directed to the place of fishing in the form of a needle directing him. And then in his local language, he is given alert about the impending dangers, if any, in the coming days. If weather vagaries like heavy winds are going to happen, or if sea state roughness is going to increase tremendously, the fisherman will be given a warning in his local language. Not only that, if the fisherman reaches the international boundary, then also he is alerted. So all this is happening on his handheld mobile in his local language, and the fisherman doesn't have to read anything. He gets the needle for pointing to where he has to go for fishing, and audio in local language for getting any alert. So this is the kind of mechanism that has been done using this whole combination of satellite taking images in 8 different spectral bands, and then the thermal front together, generating a prospective fishing zone map for the entire country's coastal area, and through the Navik satellite system providing him specific information. This shows how this whole process is done.
Navigation with Indian Constellation, a 7-satellite regional system, provides position, navigation and timing services over the Indian territory and 1,500 kilometers beyond its boundaries.
This is a gadget what you're talking about. It is a small gadget which gets fitted to the phone.
Among the many benefits of NAVIC, significant are a wide variety of services that the fisherman community derive from it. The mobile phone in the hands of a fisherman talks to the NAVIC receiver using Bluetooth and provides him with a wealth of information that not only direct him to the potential fishing zone but also ensures his safety at sea during times of bad weather and also alerts him against crossing the territorial waters while at sea.
You are outside the international boundary and are unsafe.
ನೀವು ಅಂತಾರಾಷ್ಟ್ರೀಯ ಸೀಮಾರೇಖೆಯ ಹೊರಗಡೆ ಹೋಗಿರುವಿರಿ ಹಾಗೂ ಅಸುರಕ್ಷಿತವಾಗಿರುವಿರಿ.
Using a fisherman app, the fisherman can receive the information on potential fishing zone, which is nothing but the area where there is a dense concentration of fish population. Apart from identifying the potential fishing zone area, NAVIC also guides and navigates the fishing community towards this location. Thus, a considerable amount of time, efforts and cost is saved, while at the same time there is a good fish catch. Besides, using the position information of the fisherman, the NAVIC also alerts the seaborne fisherman against crossing the territorial waters.
आप अंतर्राष्ट्रीय सीमा रेखा से बाहर हैं और असुरक्षित.
Experiments were conducted in the Tumba beach was actually fulfilled, and today with each increasing capability that the Indian Space Research Organization is bringing, we are able to communicate and provide very useful information to the fishermen. And what this slide shows is, of course, our geo or the geostationary satellite constellation, which started in the year 1990. 1990 was the 92 is the indigenous version, and 82 onwards we had the first series of INSAT satellites providing communication, broadcasting and meteorology, all three in one. Here also what ISRO did is again very unique. For the first time, a satellite was used for providing three different functionalities in a single satellite, and at that point of time the 3-axis stabilized satellites were not in vogue, and ISRO had to conceive this and use this particular mechanism because we could not afford 3 independent launches and 3 independent satellites providing the functionality. And the first generation was built by an American company as per our requirement, but second generation onwards, the entire set of satellites is built indigenously. Today, we have more than 15 communication satellites and 7 navigation satellites providing us information for broadcasting, direct to home, VSAT connectivity, and many other communication applications. And we also have a series of low Earth orbiting satellites which provide OceanSat-1 is what I mentioned, which was capable of providing for the prospective fishing zone information to be generated. And we were among the first to develop a very high resolution camera, 360 meter resolution for ocean observation in this domain. And we also have a number of other satellites which provides us capability today. Now in terms of weather monitoring, what we have today is every 15 minutes we are able to look at what is happening around India in almost something like 25 different spectral bands, 6 spectral bands varying in resolution from 1 kilometer to 4 kilometers, and then 19 channel sounder which helps in creating vertical temperature and humidity profile And all this information goes into the numerical weather forecasting model, and IMD is able to provide improved weather resolution, weather information, and also the cyclone information, which is one of the very significant developments, because many of you would remember that in the earlier decades, if a super cyclone were to strike any of the coastal regions, tens of thousands of people used to lose their lives. But today, with the help of the imaging that you can do from the satellites and the information that can be generated, at least 4 days in advance, you can inform the disaster relief agency about the impending danger of where the cyclone is going to hit the land within an error of 20 kilometers in space and half an hour in time. As a result of that, disaster relief agency is in a position to evacuate the people and save their lives. And in the past few super cyclone occurrences, the loss of life has reduced to a single digit number. And if this has happened, the major credit for this has to go for the information that is generated from the satellites. And we have a website called Meteorology and Oceanographic Science Data Archival Center, where not only all the image data that is acquired using our own satellite, but also the data acquired among many international community that is also hosted here. And this data is used for providing some cloudburst or heavy rain events, and then intense rain events, and weather forecast to almost 1,700 locations in the country at every 3-hour interval on an experimental basis with a spatial resolution of better than few kilometers is done. And then sea state forecast is done to help both our Navy team and the people who go into the oceans. And this is one of the very important development that has happened, providing, I think you need to go to full screen mode for the animation to work. How every 15 minutes data that is collected is used for generating a huge number of information which is being made available to the India Meteorology Department and other agencies. Atmospheric winds, rainfall, surface temperature, snow, fog, aerosol, all this information is generated using this satellites that we have today. And cyclone, like informed you, that we have a huge potential, and the cyclone centric alerts of 3D, etc. are used on a regular basis. Then in addition to this, the contributing to the national development at various stages of program implementation and monitoring. And what is done here is in terms of governance, fair and effective governance, what it requires. See, for example, efficiency and effectiveness, quick delivery of service to public, empowerment, and then ensuring development benefits to both people and the planet, entire processes, decisions, outcomes for sustainable development. All this, how it is done is, see, today we have 15 communication satellites, 7 navigation satellites, including a service called Gagan, where the Gagan-enabled receiver can help the aircraft to locate itself accurately. And this is a service which is actually certified by Director General of Civil Aviation. And all aircraft which are going to be registered in the country beyond January of 2019 are necessarily required to carry this particular receiving system. And it helps the aircraft for doing en route planning as well as for precision landing. And we have a number of Earth observation satellites which give us information about natural resources and also help us in identifying crops, crop forecast, and then ocean observation. And using, in addition, for doing all this, along with that, we need ground in situ observation, automatic weather station, agromet towers, and also Doppler weather radars. All this is also built indigenously using the technology being developed at ISRO. And the entire thing looks like this. You have a set of optical and microwave imaging system satellites providing data in multi-spatial and multi-temporal domain. Then we also have our own digital elevation model generated using cartographic images. Today for the entire country, 2.5 meter spatial resolution stereo imaging data has been generated, which will be extremely useful for various urban planning, and even for water conservation measures. This is another input which goes to this. We have a number of in-situ observation and data collection platforms. Then navigation satellite enabling position information to be determined, position and time. And then using models and techniques, this results in activities responsible for socio-economic security, sustainable development, disaster risk reduction, and governance. All this is being done completely with the technology developed within the country. Now, if you look at, for example, hand-holding with stakeholders, ministries, and departments, you have actually what was done in 2015, the present government actually brought in the secretaries of various central and state government departments, and then we also had meetings at 18 states, including Telangana and Andhra Pradesh. What can be done using the space technology? In fact, in this particular symposium, Honorable Prime Minister spoke extempore for 45 minutes, telling the various secretaries and the people who had gathered there of how space technology can be used for governance and monitoring. And because he had extensively used this technology, geospatial technology and communication technology, when he was the Chief Minister of Gujarat. And then he spoke to all the secretaries, and even subsequently 58 ministries are making use of these technologies, and more than 160 projects are going on. I'll give examples of few of them in the coming slides. See, in terms of socio-economic security, food, water, energy, health, shelter, in this, and then farmer-centric initiatives of agriculture and allied services. Today, for example, based on the satellite observations, the India Meteorology Department sends in SMS mode information to the farmers on weather information, and using the soil health card information, a farmer, depending on what crop he is growing in his field, can get advice on which set of micronutrients he should mix in the fertilizers for getting better results. And then there is also in aquaculture, one of the things that is done is the entire country's surface water map is created every 10 days, and using this, determining the sustainable water bodies, alternate livelihood to the tribals are being provided using inland fisheries. Similarly, crop insurance services, and today Mahalanobis Crop Forecasting Center in Delhi is able to provide to the government ahead of harvesting on 8 major crops what is the likely yield, which will help the government in planning whether they should allow export or import, etc. And in many of these things, and disaster risk reduction and preparation, this data is utilized. And how it enables food security is, for example, pre-harvest production estimation in major crops, including wheat, rice, sugarcane, groundnut, cotton, and jute, many of this. And then also horticulture crop inventory and site suitability and rejuvenation activities. This is also done using the satellite data. Over last 4 decades, the information which has been collected has been put into a huge database which is existing as part of Bhuvan, and then monitoring of wastelands for reclamation to bring more agricultural land under cultivation, then green revolution to eastern India, including for enabling cultivation of pulses and oil seeds, and then early warning of pests, or the type of activities that can be done. Apart from this, by continuous monitoring of the Indian subcontinent using the satellite, we are also in a position to actually tell for each location what is the probability of sunlight that is going to be available, what percentage of sunlight is going to be available, and then wind energy potential in the ocean region, and also wind wave energy. All this is being done, and the rooftop photovoltaic potential. There are actually apps which are available to the general public which can help them in planning their activities on this. Same way, the offshore wind power and wind speed information, this is all being provided to the many of the departments and department agencies. This data is also available on the web. This is a solar calculator app which has been provided. And other important thing is again in terms of telemedicine, patients can be linked to super specialty hospitals and then help the patient link to the doctor so that the need for transporting people from remote places to some extent can be avoided, and telemedicine network was established and a large number of super specialty hospitals are linked for this, and also using this data for epidemic analysis using geospatial technologies and including the spread of malaria once it starts and what areas are going to be affected can all be identified using this technology. And similarly, tele-education network was among, we had an exclusive satellite established for this, EduSat, and then today by alternate means we are trying to provide through the space technology a capability to have remote classrooms. And today, as many of you will realize, that to reach out to the entire population of our country and provide quality education, we need quality teachers, and many times this is a big challenge, and having remote classrooms can to some extent mitigate this because the expert teachers can link to a larger number of student community. And then some of the government planning and monitoring activities, if you look at Manrega, which is the Mahatma Gandhi National Rural Employment Guarantee Scheme, where the government, state and central together spends between 35 to 40,000 crores a year. In the earlier years, what used to happen is whatever activity that is done, there was no proper record of this database existing. But since August last year, ISRO along with NIC and the Department of the Rural Health and Rural Population from central government have brought in more than 2.5 crore assets created in this Manrega into the Bowen database, and any citizen can actually log in and see what is the activity that is happening, what is the progress, and this is growing almost every day. 1 lakh new assets are coming into the database, and this will bring in a huge amount of transparency both in governance and also the people's ability to monitor and then contribute to this. And similarly for watershed development, using the satellite-based water body monitoring as well as the what you can call as the digital elevation model data, using gravity gradients for linking water bodies, the huge amount of work is going on. And then this is another very important aspect where empowering the grassroots level planning. One of the activities we are trying to do is what is called space-based information system for decentralized planning. Here we are attempting to bring in the entire country's village assets into a database and then help the elected representative of the villages, sarpanch and the others, to understand the assets which exist not only in their region, in the surrounding their region, and also by bringing in decades of information about how things have changed over a period of time and what programs of state and central governments are currently running under which planning can be done. These activities we are trying to do with the student community, and many of the institutions like Periyar University has adopted 100 villages, and a set of 300 teachers and students together in Mudbidri, in one of the taluks of Karnataka, they have completed their database creation for one taluk, and that is they are taking it up further for the entire district. And here again, I was just mentioning to the principals while we were traveling, there is tremendous opportunity for institutions like this to make a difference to the society around you by bringing in the benefits of space technology to the society. This is again a very interesting experiment which is in progress. See, many of you are aware that we have more than 4,000 heritage sites in the country. Earlier, as per the rules, within a certain restricted area of the heritage site, you cannot do any construction, but there is an area where with permission you can do, and beyond a certain area there are no restrictions. But since these demarcations were not accurately available, the whole process used to take years. But since May of last year, the Ministry of Culture has made this whole process online, and any citizen can apply for the construction by giving the geographical data boundary of his region of interest and get the clearance within a matter of weeks. And we have also gone one step further, and we have brought in a, you can say, standard operating procedure where each of these heritage sites, we want to create a 3D city model. That means a group of students, civil engineering, computer engineering, software, physics, chemistry, a set of students can form a team and then go to this heritage site, walk around that place using the mobiles, a set of mobiles, take pictures, and using the software, then they can create a 3D city model of that. And then that 3D city model not only helps the Department of Culture to record what exists today, so that for future when changes are there, how they are changing, and also bring in this information as a virtual walkthrough for tourism department and the like. So we have initiated this process, and a number of academic institutions have started taking up projects, 3 to 4 months project, where the students also get a tremendous opportunity to learn the intricacies of software, hardware, linkages, and then also the project they do become useful for the country. And then in terms of aquaculture planning, like I pointed out earlier, in terms of identifying the water bodies and the surface water map, even Telangana government, we have signed an MOU where for the Kakatiya mission, we provide the surface water map every 10 days, and very soon it's going to become every 5 days. The entire surface water map is provided to them, and along with the in situ observation they have plans for water management. And this data can also be used for providing alternate livelihood to the tribals, and that's what the tribals department has done. So this just shows you how the water body surface water map which is generated can help in this kind of activities. You can see the changes that are taking place as the days go by, the amount of water that is available in this thing. So such data is getting generated, and they become more and more real time as our capacity increases. And then we also have been doing over a period of time identifying the specific location where bore wells can be drilled. As you can imagine that when you look at the data in large scale, the fault lines and the geological features help us in identifying the probable areas where water can get accumulated. And today for the entire country, at 3 levels, 3 depths, and at 3 different yield levels, first cut of information can be provided using this. But then following this, a geotechnical survey in a small area helps in identifying where to drill the bore well. This technology has been done, and more than 4 lakh bore wells drilled across the country over a period of 3 decades have demonstrated the success of this particular system. And this is another program where actually what happens is, using the space technology, when you come up with a new way of doing things, it's not easy for us to convince the user department that they should adopt this methodology and go ahead. This is one example where way back in '69, the first experiment was done using remote sensing, coconut root wilt disease, which was done. But then gradually over the period of time, almost 3 to 3.5 decades, using satellite data, FUSL, what is called forecasting agricultural output, using space agrometeorology based information. And since 2012, the Mahalanobis Crop Forecasting Center has taken up this task, and at national level for these kharif rice, rabi rice, wheat, jute, potato, as well as mustard, and also wheat, cotton, mustard, and sorghum, sugarcane. For these, it is providing the information to the country. And then the crop acreage and estimation, this is a detail. First estimate is given in an early time, and then the third estimate just before the harvesting. Other important aspect of space technology data collection is its contribution to climate change impact studies. As you can easily understand, that space does not see state boundaries or national boundaries. So you can collect the information about the entire globe and entire atmosphere. And today, a large number of glacier studies, if you have to do in a systematic manner, it's only the satellite data that can help you, because in situ going to those places are very hazardous and you cannot monitor them. And using this, more than 2018 glaciers have been studied, and which showed in about 1700 glaciers no change had occurred, and 248 had retreated and 18 had advanced. This kind of data also provided, actually corroborated and also put to rest some hypothesis that was being made that a lot of glaciers are actually retreating. Now aerosol climatology and including the studies in the Antarctic and Arctic polar regions, what is the amount of polar ice that gets formed, how it increases over a period of the year and decreases, all such data can be studied using the satellite data. And then this is another very interesting slide. You can see here from the Gulf how sandstorm comes right up to the Mumbai here, and this entire sandstorm with its origin in the deserts of Gulf, and then it produces significant impact in the Mumbai, and then it produces aerosol and other effects, and for such air quality monitoring also satellite data helps. Then tele-education, I touched upon this already, and a number of vocational training and then interactive classrooms. And while this was started in the early years when the satellite technology was much better with respect to communication on ground, but with the terrestrial fiber connectivity being available, the activity shifted to terrestrial connectivity. And then watershed monitoring, here by linking the activity along with the farmers and showcasing to them, showing them the maps in the form of Rangoli so that they can understand the whole process very easily. The activities were done, and this particular program got the World Bank award for the way space program was utilized for improving the water body rejuvenation and then preserving water in the various wells. And then integrated watershed management program. This is another activity which is done using the satellite data, and also for reducing the poverty mitigation activities. Some of this we have already seen already. And then agricultural drought. This is again in terms of by studying the meteorological parameters, the hydrological parameter and agricultural parameters, and the data that is collected from the satellite, you can do this drought assessment using various indices that can be generated, and using such indices you can identify which areas are more affected and which areas are less affected. And then providing safety net for building resilience or technology, and whether it is for in terms of agricultural risk information or high resolution satellite data for coastal mapping, crop assessment, crop damage. In fact, crop damage also is one of the areas where crop insurance dissemination requires very specific input, and crowdsourcing methods are becoming very important in this. While we were doing all this, we also did space science activity. In 2008, we did the first lunar exploration, and you will be extremely happy to learn that though India did its lunar program much later than others, and while others had already landed on the moon, a large number of probes had gone around the moon, the real credit for discovering the process of water molecule formation and presence of water on moon, the credit actually goes to Chandrayaan-1. And in the same manner, if you look at Mars mission when we undertook, the success rate of this mission was only 40%. Among the 53 odd attempts which various countries had done, only 22 had succeeded. And when we demonstrated that in our maiden attempt, we were able to put a satellite around the Mars successfully, the entire world turned around and looked at India to see how it has become possible. To appreciate the kind of complexity that is involved in this particular mission, if you are told on the 5th of November when we launched the satellite from Sri Harikota, and which showed in about 1700 glaciers no change had occurred, and 248 had retreated and 18 had advanced. This kind of data also provided actually corroborated and also put to rest some hypothesis that was being made that a lot of glaciers are actually retreating. Now aerosol climatology and including the studies in the Antarctic and Arctic polar regions, what is the amount of polar ice that gets formed, how it increases over a period of the year and decreases, all such data can be studied using the satellite data. And then this is another very interesting slide. You can see here from the Gulf how sandstorm comes right up to the Mumbai here, and this entire sandstorm with its origin in the deserts of Gulf, and then it produces significant impact in the Mumbai, and then it produces aerosol and other effects, and for such air quality monitoring also satellite data helps. Then tele-education, I touched upon this already, and a number of vocational training and then interactive classrooms. And while this was started in the early years when the satellite technology was much better with respect to communication on ground, but with the terrestrial fiber connectivity being available, the activity shifted to terrestrial connectivity. And then watershed monitoring, here by linking the activity along with the farmers and showcasing to them, showing them the maps in the form of Rangoli so that they can understand the whole process very easily. The activities were done, and this particular program got the World Bank award for the way space program was utilized for improving the water body rejuvenation and then preserving water in the various wells. And then integrated watershed management program. This is another activity which is done using the satellite data, and also for reducing the poverty mitigation activities. Some of this we have already seen already. And then agricultural drought. This is again in terms of by studying the meteorological parameters, the hydrological parameter and agricultural parameters, and the data that is collected from the satellite, you can do this drought assessment using various indices that can be generated, and using such indices you can identify which areas are more affected and which areas are less affected. And then providing safety net for building resilience or technology, and whether it is for in terms of agricultural risk information or high resolution satellite data for coastal mapping, crop assessment, crop damage. In fact, crop damage also is one of the areas where crop insurance dissemination requires very specific input, and crowdsourcing methods are becoming very important in this. While we were doing all this, we also did space science activity. In 2008, we did the first lunar exploration, and you will be extremely happy to learn that though India did its lunar program much later than others, and while others had already landed on the moon, a large number of probes had gone around the moon, the real credit for discovering the process of water molecule formation and presence of water on moon, the credit actually goes to Chandrayaan-1. And in the same manner, if you look at Mars mission when we undertook, the success rate of this mission was only 40%. Among the 53 odd attempts which various countries had done, only 22 had succeeded. And when we demonstrated that in our maiden attempt, we were able to put a satellite around the Mars successfully, the entire world turned around and looked at India to see how it has become possible. To appreciate the kind of complexity that is involved in this particular mission, if you are told on the 5th of November when we launched the satellite from Sriharikota, travel for about 10 months, a distance of 600 million kilometers, and on the 24th of September 2014, morning 7:30 a.m. to the second, the satellite should have been in space in a cube of 50 kilometers. you imagine a cube of 50 kilometers and place it somewhere in the outer space and say this object of our satellite, after traveling 10 months and 600 million kilometers, it should be inside that cube. If it had not happened, we would not have been able to actually put the satellite into the Mars orbit. And what kind of forces could have deviated the trajectory of this satellite? Even the sunlight falling on the satellite can produce enough force on the satellite to change its trajectory. So one other thing is you had to continuously monitor the satellite, make sure that it is on the right trajectory and give corrections if necessary, and then ensure at that particular time it is at that location. Then only you could reduce its velocity and get captured by the Mars gravitational influence. It was for the first time we were going out of the Earth gravitational field, because all our previous missions, including lunar mission, is within the Earth's gravitational sphere of influence. So the Mars, we had to go out of the Earth's gravitational field, get into heliosphere, and then go close to Mars and get captured. Another very interesting thing was this command which you give to the satellite takes almost 14 minutes when it is at the farthest from Earth to reach. That means the light which travels at 3 lakh kilometers per second takes 14 minutes to reach the satellite. Many times when you start a computer, if it takes little more time for booting up, you will be fidgety. You will be saying how slow this computer is. So you imagine the people sitting at the control center having given the command, having to wait for half an hour to know what has happened, how they would be feeling at that point of time. So notwithstanding this, the satellite itself, the launch was successful, and the entire process, we had originally planned for operation of only 6 months, but we have already completed 3 years, and very soon it's going to become 4 years of operation. And not only that, it's going to last for many more years, and a large number of data is being collected using that. And another very interesting satellite that we launched is what is called a space astronomy satellite, AstroSat. And you can see the kind of details that this is providing. And in fact, in this particular satellite, all the instruments were built in the academic institutions of our country. The telescopes were built at Indian Institute of Astrophysics, Bangalore, Inter-University Center for Astronomy and Astrophysics, Pune, the Tata Institute of Fundamental Research, Mumbai, Raman Research Institute, etc. And you will be extremely happy to learn that the far ultraviolet telescope which is carried by this satellite has the highest angular resolution among any telescopes in the world. We have a 2 arc-second angular resolution, and the next best is 6 arc-second. So this particular satellite has a capability to study transient phenomena of the celestial object, and it has already made very significant impact in the global observation scenario. It also participated in the neutron star collision as well as the gravity wave monitoring related activities which happened. In both of these, this satellite has helped. Not only that, the student community in our country have an opportunity to task this satellite and request for data to be provided for research. So this is one of the first occasions where Indian researchers have priority over anybody else. And then today you can also see some of the data that has been collected by the Mars satellite, and this particular information of global albedo using the Mars data has been generated for the first time, because this particular wavelength, no observation had been done earlier. And also some of the results, what it has already shown, it has shown that there are mechanisms on Mars where dust goes up to the height of 200 plus kilometers. Such information was not known earlier. Mars, our orbiter mission, is already making quite a bit of significant changes to the knowledge of the scientific community. Here you can also see the very peculiar shape of the object. It almost looks like a penguin here, but this is an image of the Mars. For doing all this, like I said, we started with the sounding rockets in the 60s, and today on the January 18th, when we launched our PSLV, we have completed 162 missions, out of which 39 consecutively successful flights of PSLV happened. Of course, last August we had one break in that, but then this January we demonstrated that was actually a very peculiar problem which resulted in failure. There is nothing basically wrong with the system, and today we have 40 successful launches, and we have developed our indigenous cryo engines, and we have 2 versions of geostationary launch vehicles. We have a 4-ton capacity and a 2-ton capacity satellite launching capability, and then we have 100 satellites built at ISRO Satellite Center launched, then Chandrayaan, Mars and Astrosat science mission, space capsule recovery experiments, and then see what we need to realize is while we keep building our capability, the technology is moving fast, and unless you keep yourself abreast of the newer things that is happening and do research, very soon you can be left behind. So you need to make sure that while we build a capacity today, you also need to keep looking at how to improve on things. Towards this, we had the reusable launch vehicle technology demonstrator and the scramjet engine. We'll see some slides subsequently. And while we built all this, and it was primarily meant for launching our own satellite, we have made use of it for putting 237 satellites of 29 countries into orbit. And last year in the month of February, when in a single launch, 104 satellites was put into orbit by PSLV, again, the world turned around and looked at India, what's happening here? So like I said, starting from 63 with the sounding rockets, which came in the form of kits, gradually we built up our capacity, and today we have a large number of launches taking place. Today we are gearing up for putting 1 launch every month, and then the scramjet engine. Here again, it's a very interesting experiment, where as you can visualize in a cryo engine, you are making use of liquid oxygen and liquid hydrogen as fuel. Now oxygen, if you are able to pick up oxygen in the atmosphere, then you don't have to carry that when you are launching. Where we picked up the oxygen from the atmosphere and hydrogen was carried in this particular engine. And for about 18 seconds, we were able to sustain the flame, and we were among the very few agencies globally to successfully conduct such an experiment. But still, we have a long way to go. These are all very preliminary experiments before it can become a fully operational system. A large amount of research has to happen, and I'm sure many of you sitting here will have opportunity to work in such exciting areas. And when you want to bring objects from space back to Earth, you need to make sure that as you enter the atmosphere, because of the friction, the amount of heat that is generated, objects inside, if they have to survive, then you need to have special thermal treatment system, and such things. Satellite recovery experiment was done, and then in 2007 this happened. Then subsequently we also had the recovery of the crew module in the 2014, and then the wing body re-entry. Here again, for the first time, a wing body which went up to a height Mach number of 6 and up to 1000 degrees centigrade, it was brought back and virtually landed on Earth. This shows you the way in which we built our capacity of PSLV, starting with an 800 kilogram launch in the year 1994. With each launch, we went on improving the capability of the launch vehicle. In fact, when we launched in 2002, a satellite called Kalpana was the astronaut who perished in one of the NASA launches. The satellite was named after her. It was the first launch vehicle actually which, without a cryo engine, put a satellite into geostationary transfer orbit. And then gradually Chandrayaan mission was done using this launch vehicle. Then you had 104 satellites going into this. And you can see as early as 2008, the 10 satellites had been put into orbit using this, and progressively 104 satellites in a single launch was again a huge development. What is involved in that, if you want to appreciate, a vehicle is moving at 7.5 kilometers per second, and every few tens of milliseconds you are releasing objects from it, 104 of them. They should come out without colliding with each other and without interfering with each other's path. And you have to do a huge amount of simulations and Monte Carlo simulations and analysis to ensure the orientation of the satellite, the instant at which you release, and all that was successfully done. Similarly, this is a indigenous development of cryogenic engine. Today we have successfully done 4 cryogenic engines, and this month, again towards the end of this month, the next flight is going to occur. And we also built the cryogenic engine for the GSLV Mark III, where last year we had the first successful launch. It had to go through a huge number of tests, more than 250 tests, to demonstrate the capability of, and here again we were able to achieve success in our maiden attempt. And then these two you have already heard about, the RLVTD as well as the scramjet engine. And then in doing all this, one of the other important things that we need to understand is we started the whole activity much later than others, and unless you innovate and make things differently from what others are doing, you will not be able to catch up with them. And in whether it was a communication satellite of 3-in-1 or navigation satellite where instead of what the rest of the world did, 24 to 32 satellite constellation, we did only 7 satellite constellation to provide geographic positioning system for our country and immediately surrounding our country up to 1500 kilometers, or in the remote sensing. In all these areas, we came up with very different ideas from rest of the world. And this particular capability, what is called a 3-tier imaging system, which was specifically designed to suit the agricultural information requirements of our country, helped us go ahead of others. Between 1995 and 99, India had the highest spatial resolution imaging capability in civilian domain. In military domain, of course, there were many, but in civilian domain it was there. Then we also came up with what is called a step and stair technology for doing high resolution imaging. And like we can see through the clouds, or we can see through the glass, if there is a wavelength which can see through the clouds, it is microwave. As you can visualize, during the monsoon months, from satellite, if you were to look over India, you will see mostly clouds. So during that time, if you want to look at Earth and you want to provide useful information for rice and sugarcane type jute information, you can do it in a microwave wavelength, and we have built microwave sensors which can see through the clouds and then generate information. And while we did all this, we also had a large number of technologies developed, and we have also provided these technology transfers, including the high fire resistance paints, and then artificial polyurethane foot, and then a distress alert terminal. And also recently we have done what is called as a left ventricle assist valve. And also in terms of lithium-ion batteries, we have actually developed our own batteries which are being used both for launch vehicles as well as the satellites. And this technology is also going to be made available to the Indian industry so that they can make use of it for providing in the coming electric vehicle regimen. Okay, so that in a nutshell is what I wanted to talk to you about, how Indian Space Research Program, starting from beginnings in the 60s, where using the sounding rockets in a remote place in Tumba, the first experiments were done. Today, we are among the top 5 to 6 spacefaring nations who have an end-to-end capability of building instruments, satellites, launch vehicles, and even deep space missions like Mars mission, and manage all that indigenously. And not only that, if today world recognizes India, it is for its ability to put this space technology for societal benefits. Every country agrees that India has achieved far more in terms of bringing the fruits of this technology for societal benefits. How it has happened? It has happened because people who are working in the organization were people like you who came out of the universities and the academic institutions of our country, and who decided to stay back and stay put in our country to work for the development of our country. Many of you would realize today there is a large number of people who will be going to the Western world for the reason that there is a better quality of life there, better amenities available. So they want to take the benefit of that. But then why has it happened in those countries in that manner? How have they achieved? It is because people of those countries have put their sweat and blood and built their countries in such a way that everybody in the world wants to go there. And if tomorrow India were to become such a place, who is going to do such a thing? Definitely it is people like you who are going to do that. You who have got education in an institution built by a person who, though himself was not educated in the conventional sense. Of course, we need to distinguish. Education is not just acquiring knowledge. It is much deeper than that. Probably the person who started the educational institutions here was far more educated than any of us, because he realized that in today's world, in today's advancing technologies world, what is going to come beneficial for you is your knowledge. And if you have to acquire knowledge, you need institutions. You need institutions who can impart skills and knowledge. And all of you have had a tremendous advantage of having gone through such an institution, having seen an institution builder like this. So when you complete your knowledge acquisition and skills, you have a small responsibility. That responsibility is not only should you be looking for your own success in the world, but working as a team to solve the problems of the society and make your contributions for the improved quality of life of people around you and people of this country, people of this world, and in totality humanity. And let me wish each one of you a great success in your life, and also remind you of this small responsibility you have. And if you do that, you would definitely have paid homage to a great person who started the institution here. Thank you very much.
It's time to present our honorable guest with the Oration Award. The Oration Award consists of a cash award and a citation. And now I request the founder trustee, Dr. Nageswara Vallupalli, please come up to the stage and present the cash award to the distinguished guest. Along with the cash award, it has been customary to present a citation. Kiranam from Alur. Sir, you are a glittering star in the galaxy of ISRO chairman, an academic brilliant. In good Kannada tradition, you have carried the names of your village and family in your name, and by your exemplary life made both of them proud. Your journey started in Aluru, and the first stop was at the nearby town Hassan, where you have had an extraordinary Indian childhood with a full family of 8 siblings and parents. You went to a government school and learned from your siblings and Indian ethos. Your parents' humble tiled home became your laboratory where old electronics got a fresh lease of life, carrying your communications to your siblings. Hassan has prepared you for a career in medicine when you taught the PUC exams of Mysore University, albeit 22 days too early. Destiny had a different plan. An ardent yearner of scientific knowledge. In an innocent age, when nobody heard of breaking news, you as a youth huddled around the old college radio with friends to tune into the news of Neil Armstrong setting his foot on the moon and taking a giant leap on behalf of all mankind. You already aimed for the stars. And your journey into the scientific world thus took off in Bengaluru, passing through the famed halls of IISc. Your MTech project on imaging sensors for medical applications prepared the ground for your future career in developing space applications. The foundations for your future greatness were laid in Bengaluru, where you would return 4 decades later to head ISRO. A victor in Indian space research. You joined a Space Applications Center at Ahmedabad in 1975, and within months, sensors designed by you would take flight on Indian satellites. If currency notes were to measure the nation's priorities and pride, Aryabhatta, India's first satellite, just managed to surpass Sagar Samrat on the 1 rupee note and found its place on the 2 rupee note, thus heralding India into the space age. Today, after 100 successful satellite launches and half of them still in operation, we have overseen the constitution of a constellation of guardian angels, satellites, that constantly monitor our lands and the seas and alert us to the Adhidaivika kleshas that are about to befall us. A luminous leader of ISRO, hailing from a state whose government believes government work is God's work, and where ISRO has its major establishment, we have connected rocket science to the common man. For the sacrifice of one fishing community, which paved way with the Thumba Equatorial Launching Station, today ISRO has given back 1,000 times by guiding Indian fishermen in the seas like stars in the sky to take their catch and return home safely to their families. While no country can beat India in the dimension of time, we being the oldest of civilizations, you and your team have put India ahead in the space race and have beaten Japan and China in making it to the Red Planet on its maiden mission. An exemplary scientist of space. Shortly we will launch our second moon mission, and we are confident that under your guidance and the leadership of our rocket man, Sri Keshavan, we will have many more missions to other planets. When Hollywood has spent $100 million to make a movie called Gravity in 2013, ISRO has sent a mission to Mars and saved some. From the humble 2 rupee note, Indian space program has found its pride of place on the 2000 rupee note with Mangalyaan. The world indeed has many intelligent races, but to do a space program on a shoestring budget is not a feat that many would hope to repeat. Under the auspices of the great institution built by Sri Vikram Sarabhai, Satish Dhawan, and leadership given by successive chairmen, we have continued the great legacy and set higher expectations for ISRO. An extraordinary India. Under your tenure, ISRO has sent 100 satellites in a single launch, as well as its 100th satellite into space. May we see a day when common Indians can catch a glimpse of what we say, Vasudhaiva Kutumbakam, sitting in a rocket made in India. With our heart full of gratitude, all we can say is, Shatamanam Bhavati.